Bienvenidos, Ushamdeed, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, and Wireless Essentials version 7 course curriculum, or the SRWEv7 course curriculum. And in this activity, we're going to be looking at Packet Tracer 7.2.10, where we're going to be configuring DHCP for IPv4, or the Dynamic Host Configuration Protocol for IPv4. So let's dive in to Packet Tracer, and let's take a look at the activity as it stands. Now, this is a very nice activity here. It's going to walk us through and give us a soft landing on how to configure DHCP. And so we've got a dedicated DHCP server over here, and we're going to be talking about something that's very, very important, and that is going to be the helper address. Remember, in the skills activity, we saw that we only had a single router. Everybody was in the same broadcast domain, the same VLAN, the same subnet, and so it was very simple to configure. But as we're going to find out here, remember that the broadcast DHCP discover message, that's part of that DORA, right? Discover, offer, request, acknowledgement. The DHCP discover that our DHCP clients are sending has a source and destination IP of quad zeros for the source and all 255s for the destination, meaning everybody on that subnet. However, look at what we have here. We've got multiple routers, meaning that a DHCP client, PC1, on the 192.168.10, when it sends out its DHCP discover, it is only going to be heard by other devices on that same subnet at layer 3. And at layer 2, remember that in that DHCP discover frame, that the source MAC will be PC1's MAC address. However, the destination MAC is all Fs, as in Foxtrot. So that DHCP discover is going to get stopped naturally right there. It is not going to go this way, right? It's not going to search for a DHCP server going out this way by default, right? Let me stress that, by default. But that's what we're going to be tackling in this activity here. So let's go ahead and dive in. And again, this is a great activity. It provides us with a soft landing into configuring DHCP. So router 2 is going to be that DHCP server, and you can also see that it's running a dynamic routing protocol, specifically EIGRP, right? So we haven't talked about EIGRP, which is not covered in the version 7 NetAcad course curriculum. In any of the courses do we get into EIGRP. You'd have to go into the EN Core course before you encounter some EIGRP. All right, so router 2 looks like it is going to be doing some DHCP, and I'm sorry, this is a DNS server over here on the right, or the left. So let's go ahead and configure router 2. So let's go from user exec mode to privilege exec mode, and we're going to get into global config. Now, I'm going to be adding in an IP DHCP excluded command here to exclude the first 10 addresses. Now, here, the excluded statement, again, we have the 192.168.10.1. That's going to be this router interface on router 1. Remember, router 2 is the DHCP server, so here's a use case where we're probably going to want to include this, right, so that there's no guessing as to which addresses are included and which addresses are excluded. So we're going to say 192.168.10.1 all the way to 192.168.10.10, right? So that is excluding those first 10 addresses, and you can see we're going to pick up some percentage points, for that. And now it's immediately asking us to go ahead and do the same thing for the R3 LAN. And really all we need to do is come back and change the third octet from 10 to 30. And you'll notice we picked up 5 points for that as well. So over here to step number 2, and I'm going to keep scrolling here till we can hit the bottom. Step number 2 is let's create that DHCP pool that we're going to need. So IP DHCP pool R1-LAN. And we're actually going to be creating 2 DHCP pools. Now, we're going to put the network in here. So what is the network for which I want to be allocating DHCP addresses? And it's going to be the 192.168.10.0/24 network. Now remember, we've excluded the first 10 addresses. What's the default router value that's also going to be in that DHCP offer message that goes out, right? Where it's going to say, hey, here's an IP address for you, and it's got some additional information in there, which is going to be our default router and our DNS server, to which the client is going to make the request saying, yeah, I want that, and then the server is going to acknowledge that, right? Remember, DORA, discover, offer, request, acknowledgement. Those are sort of our 4 basic DHCP messages, and I'll mention a few of the other DHCP messages as we go along. Something else to keep in mind as we go to talk about this the IP helper address that we're going to be putting in here, and I'm going to touch on that in just a second, that there's some semantics behind what else does that forward, right? So if it forwards DHCP requests, what other things might it be forwarding as well? We need to know about that. So let's say default router 192.168.10.1, and then the DNS server. Now, note that the only thing that's required, as we saw in the skills number 2 activity, the only settings in here that are mandatory for DHCP to function are the network and the default router, right? That's it. Those 2 settings alone are enough to get DHCP to function properly. However, we've got this DHCP server in here, so let's go ahead, 192.168.20.254, whoops, and let's add that in here as our DNS server setting. So now it's asking us to do the exact same thing, different values, but the exact same process for the R3 LAN. Well, how would we do that? Well, it's wash, rinse, repeat, right? IP DHCP pool, R3 LAN. And what are we going to put in here? We're going to put in the network 192.168.30.0, which is a /24 as well. We're going to put in our default router, which is going to be 192.168.30.1. And we're going to put in the DNS server so that, everybody on the LAN segments for router 1 and 3 has a DNS server that can do DNS resolution. And we'll say 192.168.20.254. And that takes us right below 50%. So here's the problem, right? R2 is the DHCP server. So let's come down here to PC1. And this, again, is not going to work. And we know that it's not going to work, but we want to see that it doesn't work. And let's click on DHCP. I won't click on the IPv6 down here. We'll click on DHCP, and what do we get? Well, we get a link local IPv4 address. And you might be saying, hey, link local, that's only IPv6. That is not correct. The 169.254.0.0/16 range is considered your DNS, your IPv4 link local addressing. Now, it's also referred to as a PIPA addressing, APIPA, right? That automatic provisioning of IP addresses. However, these are link local. And the reason they're link local is because they are not routable, right? We typically don't route these 169.254s. So they are referred to in the RFC, which I think is 3927. It starts with a 3. But there is an RFC. If you Google RFC IPv4 addresses, you will find, and let's do that. Let's come over here, and in fact, nope, don't have it up. So let's go ahead and say IPv4 link local RFC, right? And it should be, 3927. You can see I was looking at it just the other day. And here it is, dynamic configuration of IPv4 link local addresses. So believe it or not, link local is not an IPv6 exclusive construct. So 169.254, and there it is. And here it is right here, the same physical or logical link. IPv4 link local addresses are not suitable for communications with devices not directly connected to the same physical or logical link, just like IPv6 link local addresses. Now, there are some differences in specifically that I can't put the same 169.254 on multiple router addresses because we'll get that overlapping error. However, this is a great way to do BGP peerings, right? If you're directly connected, to use a 169.254 if you don't need to be advertising that interface IP address. And so that's what we end up with here. So a quick diversion there to the RFC covering link local IPv4 addresses or those APIPA addresses. And that's what we get because DHCP is not working. So kind of transition back to the activity here. So we're not getting a DHCP address because it should be a 192.168.10. That's not what we're getting, right? And the reason we're not getting that is because the DHCP discover shows up on that router interface, and this router says, hey, I'm not configured for DHCP. I'm sorry. I can't help you. And because it's a broadcast message with the source and destination, the destination IP of all 255s and a MAC of all Fs, right? So 12 Fs, the router is not going to, by default, forward that on so that you can get help. However, we can configure the router to do that. And that's what you see over here is we're configuring a DHCP relay, right? Because again, the DHCP server here, router 2, is not on the LAN segment that PC1 is on. And I can go and close that down, that PC1 is on here. So we need to tell router 1, hey, if you're getting DHCP discover messages, we need to help out the clients who are asking to get to that DHCP server. And the way that we do that is we come onto router 1, right? We don't do this on router 2. We do it on router 1 on the router interface on which DHCP discover messages would be showing up. And that happens to be interface gigabit Ethernet 00. And what we say here is IP helper address, and we put in the IPv4 destination address for the DHCP server. And in our case, it happens to be 10.112, which is this interface, which is going to be this serial interface right here on router 2. And as I hover over it, you see serial 000, and that is the 10.112. So let's drop in this helper address here, 10.1.1.2, and you'll notice there's no work for me to do here on that interface. It's not required because we're doing it here on the router interface that gets the DHCP discover message. So I say IP helper address 10.1.1.2, and now router 1 knows that when it receives a DHCP discover, and let's click on static, and then we'll click back on DHCP, that discover message shows up here on router 1. Router 1 on that interface that gets the DHCP discover message now knows if I see DHCP discovers, I'm going to forward them to the 10.1.1.2. It's going to come up here to router 2. And the source and destination IP of that request is router 1. So router 2 gives it back to router 1, who knows that it's going to be sending it back down here to PC1. And take a look. We got our DNS server information. We've got our default gateway. We've got the subnet mask, and we've got the IP address. So let's see. Do we have connectivity? Can I ping the DNS server 192.168.20.254? So let's see if DHCP is working for me here. And again, there's some EIGRP routing configuration that's been done that's allowing this to all happen that we're not going to be digging into. But that's why that is going to function for us. And let's pull the web server up, www.cisco.com. And let's click on go. And let's see. Oh, whoops. That is not going to work because take a look here. Right? This interface is shut down on router 2. So we're probably going to have to address that first. So we'll swing back and do that right after we go ahead and configure router 3. And let me make sure I'm following along. Okay, configure the helper address on the LAN interface for router 3. And that LAN interface on router 3 is probably also going to be show IP interface brief, and it is gigabit Ethernet 00. So we get into global config, we go into gig 00, again, on router 3, on the interface on which the DHCP discover message is going to be showing up, and I put the helper address in. Now, the helper address is not 10.1.1.2. That is not the segment here. That is not going to be the transit segment IP on the opposite side for router 2. That is probably going to be 10.2.2.2, which we can quickly see. I could have pinged, but let's hover over, and yeah, it's 10 all 2s, right? So 10.2.2.2. That is going to be the address we put in here. So I put in the helper address, and you can see it bumped us up nicely. So now let's come down to PC2. Let's come to the config. Let's come over to DHCP, and let's see if we get a 192.168.30, and we do, and it's the first address outside that excluded address range. And so I'm going to save my config here. Let's say show IP DHCP binding. And there it is. We've given 2 addresses out, one on router 1's LAN, one on router 3's LAN. So that's been taken care of. We've configured the hosts to receive their addresses. We've verified that they've received the addresses from the pool because we've done the show IP DHCP binding command. And take a look here. Now we're going to configure the router as a DHCP client, right? You got to love this. But before we do that, let's talk about those helper addresses ever so briefly. Remember, the helper address is forwarding the DHCP discover messages. But what else might it be forwarding? Well, keep in mind, when I put that IP helper address command on the router 1 and router 3 interfaces, they will also be forwarding to router 2 TFTP requests, DNS requests, TACACS request. I'm trying to think here real quickly. A bootp request, right? And any kind of a NetBIOS type request would also get forwarded, right? So when you put that IP helper address command on there, it's not just DHCP information that's being relayed, right? Or sent to router 2. It's TACACS, it's TFTP, it's DNS, bootp, right? Some NetBIOS stuff could get sent. So remember that that traffic is also getting forwarded along. So now we're back on router 2. And let's say show IP interface brief, and we can see it's going to be gigabit Ethernet 01 that we're dealing with here. So let's get into gig 01. Let's first go ahead and bring the interface up. And you can see now it says interface has changed to up because we're working with an internet service provider here. Possibly they're giving us our address via DHCP. How would we do that? IP address DHCP. That's the configuration that goes on the interface of the router to make the router 2, a DHCP client as well as a DHCP server. So router 2 is serving up DHCP addresses because we configured those pools. And now when I hit enter, router 2 is also becoming a DHCP client on that interface. So let's say do show IP interface brief, and there it is, gigabit Ethernet 01. I've got the information, the DHCP IP addressing information. You can see here that my address that I received is 209.165.200.231, and there's my /27 subnet mask in dotted decimal notation, 255, 255, 255, 224. And remember, /27 because the first 3 bits have been borrowed. So it's 128, 192, 224. And that's how we end up with that information. You can see the activities moved to 100%, but do show IP DHCP bindings. We see the information there, and everything looks great. So now, if I pull the PC up and I click go, it should no longer be request timeout. We should be able to hit that web server PC2. Let's test the other web server public site. So let's go ahead and cruise over to www.publicsite.com. And there it is. All right, so some additional information that helper address is forwarding more than just those DHCP discover messages, right? Remember that. And that is going to do it for this activity, Packet Tracer 7.2.10, where we configured DHCP for IPv4, or just DHCPv4. All right, guys, let me know if you got any questions. Thanks so much for watching. And as always, I hope to see you in the next video.